Today we're going to take a look at simplifying algebraic expressions. An algebraic expression is a mathematical phrase that includes variables. In our example here, we got 3x plus 4y minus 7. The x and the y are the variables in the phrase. A numerical expression, on the other hand, is a mathematical phrase that includes numbers and symbols. In the example here, the 6 squared plus 8 divided by 2 has only numbers and mathematical operation symbols. Now you may be asking, what's a variable? A variable is a symbol, and we normally use letters, such as the x and y in the last example, that represent the value of a quantity. And a quantity is what? A quantity is anything that can be measured or counted. So, let's say we have crates of oranges and crates of apples. If we let x represent the number of oranges in any crate, and y represent the number of apples in any crate, we can figure out the total amount of fruit we have using an algebraic expression. If we take a look here, we got 1, 2, 3, 4, 5 crates of oranges. So we can represent the number of oranges by taking 5 and multiplying by the x. We have 2 crates of apples. So to figure out the total number of apples we have, we would multiply by 2. And if we want the total amount of fruit we would have, we would add the two of them together. If we've gotten in multiple shipments, we can combine like terms. Now in the first case, we have 6 crates of oranges, so 6 times 6 would be the number of oranges. We have 2 crates of apples, so an algebraic expression for the first shipment would be 6x plus 2y. In the second shipment, we've got 3 crates of oranges, 4 crates of apples. Once again, if we have those, we'd have the amount of fruit in the second shipment. And if we want the total amount, we would add both of them together. Now, if we count them all up, we see that we have 9 crates of oranges, and we have 6 crates of apples. Now, if we add the 6x and the 3x together, the 6 plus 3 would give us the 9. And if we add the 2y and the 4y, if we add those together, we would get the 6y. So if we add like terms, ones that have the same variables, we can get the same answer. Let's switch up. Let's go to chocolate. We have rectangular boxes of chocolate and heart-shaped boxes of chocolate. Let's say we have one person that gives us 2 rectangular boxes and 1 heart-shaped box. So first of all, we better pick some variables. Let's do x for the amount of candy in the rectangular boxes, y for the amount of candy in the heart-shaped boxes. So that first case with the 2 rectangular boxes, that's 2x, and we have 1 heart-shaped box. Let's say we're a lucky person, somebody else gave us some candy, they gave us 1 rectangular box and 1 heart-shaped box. If we add them together, we would see that we have a total of 3 rectangular boxes and 2 heart-shaped boxes. Once again, if we look at the like terms, if you add 2x and 1x, you would get the 3x. If you add the 1y and the 1y, we would get the 2y's. Now that's all fine and dandy, but sometimes it'd really be nice to know how much candy we actually got. And this is where evaluation comes in. This is where we're allowed to stick in numbers for the variables. Remember, the variable is anything that can be counted or measured. Now, in the rectangular box in this case, we have 15 pieces of candy. And in the heart-shaped box, I don't know if you can see this real well, but there are 24 pieces of candy. Now, by substituting in, we can find the total amount of candy we have. So we're going to put 15 in for the x, the 24 in for the y. Now we have to follow order of operations, so we're going to multiply first. The 3 times 15 will be 45. The 2 times 24 will be 48. So if we add them together, we'd see we'd have 93 pieces of chocolate. Now, the great thing about variables is you can stick in other numbers. Let's say that really isn't the size of the boxes we got, but instead, the rectangular box only has 14 pieces of candy, and the heart-shaped box only has 16 pieces of candy in it. Once again, if we want to figure out how much we have altogether, we can substitute in. So we're going to put 14 for the x, we're going to put 16 in for the y. Following order of operations, we're going to multiply first, so 3 times 14 will be 42, 2 times 16 will be 32, and in this case we have a total of 74 pieces of candy. So the thing about the variables is we can put in different numbers for the variables. Now let's run through some examples. We're basically just going to sit here and add those like terms together. So for the first example here, let's start with the x's. We got 5x and 6x. So 5 plus 6 means we have 11x. We got a 2y and an 11y. 2 plus 11 would be 13, so we'll have 13 times y. If we look at the constants, we got 18 and 9. The 18 plus 9 would be 27. So we've simplified our algebraic expression. Let's try another one. If we start with the x's, we got 8x, and then this time a minus 2x. You may be saying, wait, negative stuff? Well, this would be like if we had an inventory, and the negative would represent an order somebody makes, so we're going to take things out of the inventory. Basically, we just do our subtraction. So 8x minus 2x will be 6x. We look at the y's, we got 6y and a plus 4y. 6 plus 4 would be 10y. If we put the constants, we got 9. In this case, a minus 5, so 9 minus 5 would be 4. One more example here. If we start with the x's, we got 7x and 4x, so 7 plus 4 would be 11x. If we look at the y's, we got 2y and a negative 8y, so 2 minus 8 is actually going to give us a negative 6y. And the negative 3 and the positive 1, looking at the constants, should give us negative 2. Now, while it may be concerned if you think about our inventory example, that all of a sudden we got a negative inventory, well, this just means we have orders for more stuff than we actually have. All right, if we jump to expressions involving exponents, what we have to realize is exponents are basically a way that represent multiplying things. If we go to a geometry example, x could represent the length of a side, where x times x is the second power, would represent a square, and x times x times x cubed, it actually physically represents a cube. Same can be done with y, where y could represent the length of a side, y times y, or y to the second power, would be a square, and y times y would be the representation of y to the third, or a cube. Notice none of them are the same size or shape, so we cannot keep add any of those things together. If we start mixing in the x's and y's, x times y would make a rectangle. In this case, x times y would make a prism, where 2 of the sides matching are the x's, whereas x times y would be another prism, different size and shape. Once again, the variables and the exponents have to match exactly before we can add any of the like terms. All right, a couple last examples. Let's do this one. We got 5x squared and a minus 2x squared. So 5 minus 2 would be 3x squared. Next, we got the minus 6y squared and a plus 3y squared. Negative 6 plus 3 would give us a negative 3, so that's still y squared. Moving on, we got 8x and a plus 2x. 8 plus 2 would be 10x. The minus 7y and the plus 9y. Negative 7 plus 9 would be a positive 2y. And if we go to our constants, we got the plus 4 and the minus 11. 4 minus 11 would give us negative 7. Notice we do not change exponents, because if we change exponents, we're changing the shape that we were just looking at. All right, one last example. All right, we got 5x and a minus x, so 5x minus x, or minus 1x, would be 4x. We got a minus 2xy and a plus 3xy, so negative 2xy plus 3xy would be a positive 1xy. Some people write this without the 1 in front. Let's see, we got the 8y and the 4y. 8 plus 4 would be 12y. And that leaves us a 9xy squared, which matches up with nothing, so we just have to carry that down. Well, I hope this helps you with learning about simplifying algebraic expressions. I wish you good luck.